Hello, good morning students. Welcome to one more amazing session from Infinity Learn. This is Suresh, Faculty of Chemistry. आज हम चर्चा करने वाले हैं thermochemical equations. In the previous session, we had a discussion about thermodynamics in the physical aspect of thermodynamics. In the Neet 2026 preparation, we are coming up with one shot sessions. In the previous session, we had a thermodynamics. It is completely based on first law, second law, and third law and zeroth law we discussed. And we had Gibbs free energy change, internal energy, and enthalpy. And today in the session we are going to talk about thermochemical equation. We are going to take this enthalpy what we learned in the first session, in the first law of thermodynamics, and we are going to apply the same concept in chemical reactions. That is nothing but it is your thermochemical equations. No doubt about that. Thermodynamics, chemical thermodynamics gives you one question definitely for the NEET examination. So definitely I can say take a pen and paper and follow the session throughout, and I am going to tell you all the concepts including very good numericals, and also tricks to solve numericals are also there with you. And please confirm, can you all able to see me? Can you all able to hear me? Just one thumbs up and fire emojis so that we can start the session. And thermochemical equation. So in this thermochemical equation, hi Varnam Devi, I think you can hear me. Yeah. So what is the importance of need of thermochemistry? So we learned thermodynamic basic principles. We are going to apply the thermodynamics principles in the thermochemical equation. So in a chemical equation, reactant gives rise to the product. And during this course of this, reactant transformed into the product, heat may be going in or heat may be coming out. So that could be endothermic reaction or that could be endothermic exothermic reaction. So we'll see it. How much heat is involved in the thermochemical transformation? So that is the basic need of thermochemistry. Thermochemistry provides a theoretical approach for calculating heat changes in a chemical reaction. And performing an experiment calculating heat change in a reaction can be calculated, and it can be experimentally and it can be theoretically, you can do it. So I want to say thermochemistry is a study of energy transfer during the course of the complete chemical reaction. In this scenario, you can say the factors affecting enthalpy change. I want to say here reactant is converted into the product. So during this course, the enthalpy change can be calculated. So enthalpy change for this reaction is equal to sum of the enthalpies of the products minus sum of the enthalpy of the reactant. एक ही formula है. You may say that total thermodynamics is completely hell numericals and you will be having very good number of formulas. That may be a perception, but so total thermochemistry is revolving around this particular formula. Can you believe it? And depending upon that type of reaction, we are going to define various formats of the enthalpies. So let's talk about the enthalpy change of a particular reaction depends upon the various factors. Physical state of the reactant and the product, and allotrope form of the reactant and the product. You can say carbon graphite burn with oxygen gives rise to carbon dioxide. Enthalpy change is different, and carbon in the form of diamond allotrope react with oxygen burning to give us carbon dioxide. इसका enthalpy change बिल्कुल अलग होता है. So that you need to know allotropic form भी दिखाना पड़ता है chemical thermochemical equation में. Every point I want to tell you, and also amount of the reactants definitely 1 gram लेने तो delta H अलग होगा, 10 gram लेने तो delta H अलग होता. And also temperature. I want to let you know the detailed version of the temperature dependence of the reaction Kirchhoff equation का हिसाब से. So, बच्चों moving ahead, take a pen and paper, write all the noteworthy points. अगर कुछ doubt आ गए तो you can use the chart box and you can discuss with us. And here I want to talk about enthalpy of a reaction. This is the only thing you need to see in the entire thermochemistry, and the enthalpy change when the amounts of the total reactants are consumed and transformed into the products as shown in the equation and according to the corresponding stoichiometric numbers and expressed in moles, and this is called enthalpy of the reaction. That reaction could be any type of reaction, चाहे ये reaction combustion reaction होगा, ये reaction formation reaction होगा, ये reaction neutralization reaction होगा, and hydrogenation reaction होगा, ionization reaction होगा, जो भी हो सकता है, and enthalpy of reaction only will see. So the enthalpy of reaction could be positive and could be negative. And let's see, methane is burning in oxygen, gives us carbon dioxide and water, and you know the enthalpy of the reaction is calculated experimentally, supposed to be minus 890 kilojoules per mole. And whenever you see these values, you never and ever by heart any values except enthalpy of neutralization. शायद enthalpy of neutralization ये value भी देना पड़ता है ये question paper का हिसाब से, but you don't have to memorize any value. Better here per mole in enthalpy of reaction means per mole of the CH4, per 2 mole of oxygen per mole of carbon dioxide is formed, per 2 mole of H2O is going to be formed. So the way you have to understand per mole, kilojoule per mole, a dimension का analysis काफ़ी important है. Enthalpy of reaction refers to the entire chemical equation as shown here at any particular reactant with respect to the reactant or with respect to the product. You need to understand here, and it depends on various points like physical state, allotropic forms, and the temperature and various forms. So thermochemical equation में क्या क्या दिखाना है. So let us talk about enthalpy of reaction that can be calculated, the difference between enthalpy of the products minus sum of the enthalpy of the reactants. In this, stoichiometric coefficients you have to take into the consideration, and stoichiometric coefficients and the molar enthalpies are taken into the consideration. Looking little clumsy, so let us not consider that clumsy part. If you feel it is so clumsy, you can say enthalpy of reaction is equal to sum of the enthalpy of the product minus sum of the enthalpy of the reactant. बच्चों here हमेशा जो भी इक्वेशन है प्रोडक्ट माइनस रिएक्टेंट, प्रोडक्ट माइनस रिएक्टेंट और प्रोडक्ट माइनस रिएक्टेंट, लेकिन एक ही जगह पे रिएक्टेंट माइनस प्रोडक्ट आ सकता है. If anybody knows that, please mention in the chat box so that I'll tell you what is that exactly. So those who are online, please like the session and share with your friends so that we will be having a very good interactive session. This is a live interactive session. You can get use of these sessions for free of cost. You just simply say hi in the chat box. Okay, so to explore. So coming to the answer to my question, my dear children, here we are almost comes to the end of 2025 and you are getting into the 2026. So 2026 का resolution क्या, and it is going to be 2026 is a big year. So you are going to write your awesome Neet 2026, right? And also you are going to enter into your dream medical college in the same 2026. Get ready to meet your new friends in your dream medical college, right? How many of you agree with me? And for that, what is the resolution for 2026? Simple. I don't want to give much motivational speech. Trust your preparation and believe in yourself, and go to Neet examination and write, give your best and get the best. Don't leave the marks on the table. Grab the marks and put your name in the rank list, right? So my dear children, here I just want to say enthalpy of reaction here. Enthalpy of reaction, it could be a negative or it could be a positive or it could be zero. Thermo neutral zero hoga and negative hoga to exothermic hoga, positive and to endothermic hoga. Here how do I write here? The enthalpy of reaction, okay, you can say that is equal, sum means enthalpy of carbon dioxide plus enthalpy of water into 2 minus enthalpy of CH4 plus enthalpy of oxygen into 2. So simply like this, and for your convenience sake the molar enthalpies and the denominations are being given. And if you see these enthalpies, enthalpy change for a reaction when all the participating substances are in their standard state. A standard state hoga kya? A standard state enthalpy of reaction, you can also say, and standard enthalpy of reaction, that is identified given as delta H or not. So what is this standard state? जब temperature 298 होगा and pressure 1 bar hoga, thermodynamic standard condition. In thermodynamic standard state of a substance, a specified temperature in the pure form at 1 bar pressure is called standard state. Here that 0, so this is what you write as standard. So that 0 you write represents the standard condition. Chahe ye enthalpy, standard Gibbs free energy, standard standard entropy, standard cell potential. So these are the various standard state that you come across with that. Any parameter it is given not, it is said to be standard state. When temperature is equal to 298 Kelvin and the pressure is equal to 1 bar, it is said to be standard states. And this standard state are, Sahil, you have a question? You just ask your question. Those students who are online, you are free to ask a question. So I am ready and happy to answer your question. Moving ahead, in this standard state hoga for a pure crystalline solid 1 bar pressure at specified temperature, and for substance or an ion in a solution it should be 1 molar concentration. Everybody knows this, but nobody knows this. It is given in the textbook and you need to. When the concentration is 1 molar at 1 bar pressure at a specified temperature is a standard state. For a liquid, pure liquid at 1 bar pressure at a specified temperature, this is for the state of matter. For the gases, the ideal gas 1 bar pressure, the partial pressure and the specified temperature. जब temperature है ना 298 Kelvin में होगा, मान के चलो, right beta? After completion of this basic concepts, Sahil, I am going to give you a very good numericals which covers all concepts. Okay, no worries, stay tuned beta. Sahil, and standard state of a liquid ethanol at 298 Kelvin is pure liquid ethanol at 1 bar pressure, and the standard state of iron at 500 Kelvin is pure iron at 1 bar pressure. So you need to be very clear about the concept. Simply looking at the numerical and jumping into the numerical, it may potentially damage the performance. So let us say thermochemical equation. So if we want to calculate the equations and numericals and thermodynamics and thermochemistry, you need to have a thermochemical equation. It should be balanced. Thermochemical equation should be balanced and it should include the enthalpy change. So balanced chemical equation with the value of enthalpy change along with the physical state along with the allotropic form should be given. That is called thermochemical equation. Here N2 plus 3H2 gives us 2NH3 and delta H is going to be minus 91.8. Please don't memorize this value, my dear students. Sahil, I will be starting the numericals. Wait for a while, right? Similarly, you can say the same thing here. If you reverse this equation, you are going to have, so 2NH3 gives us N2 plus 3H2, and it will be given plus 91.3. So I want to say, if A gives rise to B and delta H is going to be minus X kilojoule होगा, तो जब a reaction B gives rise to A and delta H is supposed to be plus X kilojoules होगा beta, right? This is the key point. If you know this key point, you can handle so many numericals. And also, if you want to write 2A plus 2B, so delta H is supposed to be minus 2X kilojoules होगा. If half A gives rise to half B, delta H is going to be minus X by 2 kilojoules होगा, right? And this is the key points. These are the key points that are required to handle numericals in thermochemistry. Fine. And also you can see, similarly multiply with half, you are going to get the value half of it, and multiply with 2, you are going to get double the value. So that I want to say, minus 2 into 91 point, how much it is given? 3. Okay. And also Hess law of constant heat of summation. Hess law of constant heat of summation says, if a reaction takes place in a single step or takes place in multiple steps, the enthalpy of reaction is going to be same. That is called Hess law of constant heat of summation. Let us say A gives rise to B, so enthalpy of reaction is there. So in a single step, in a multiple step, A can give rise to C, H1, C can give rise to D, H2, D can give rise to B, H3. So enthalpy of reaction is going to be sum of H1, H2, H3. That is what is called as Hess law of constant heat of summation, right? So these are the various applications I just want to show. NaHCO3 gives rise Na2CO3 plus CO2 plus H2O. Enthalpy of reaction क्या होगा? And it is given sub reactions. Sodium bicarbonate react with HCl gives rise NaCl CO2 H2O, and its value is delta H1. And Na2CO3 plus 2HCl gives rise NaCl plus CO2 plus H2O, delta H2 is given. That is the given data. Now look at this. Na2CO3 is there in the product side. NaHCO3 is there in the reactant side. Now look at these next two reactions, you will understand what makes the difference between these two. Here NaHCO3 in the reactant side and Na2CO3 in the product side. So you have to reverse this, and I want 2 NaHCO3. So first reaction is multiplied with 2 and second reaction is reversed, so that you are going to get the first reaction. So I want to say, multiply the equation 1 by 2 and subtracting the equation 2 from equation 1. So I mean to reverse this. So you are going to get enthalpy of reaction is equal to 2 into enthalpy of 1 minus enthalpy of 2. So this is the key point you need to understand. This is how you have to do. So if you do so, 4 marks will be yours. Agree with me? Agree with me? Sahil? Moving ahead, standard enthalpy of formation. So enthalpy change for the formation of 1 mole of a substance from its constituent elemental substance is called standard enthalpy of formation. So here H2 plus half O2 gives rise H2O in the liquid state. So you need to understand, standard state में H2O a liquid form में होना चाहिए. That is the first condition. Second condition, 1 mole of the substance should be formed, right? And the third condition, and the reactants are supposed to be in the elemental state. Then only the enthalpy change that you are going to calculate here is going to be standard enthalpy of formation. So ज़्यादा काफ़ी न्यूमेरिकल्स थर्मोकेमिस्ट्री में डेफिनेशन के हिसाब से कैलकुलेट कर सकता हूँ, and that is a key point. So reference state has to be in the elemental state or reference state, and 1 mole of the compound formed. 1 mole of the compound in the standard state has to be formed, that has to be given. Okay, जो भी let it be any value, right? And that value is experimentally calculated to be minus 285 point something, right? And what is the standard state? Enthalpy of formation of a standard state substance is going to be 0. Mean to say, that's very important. So enthalpy of formation of iodine solid is 0, bromine liquid is 0, hydrogen gas is going to be 0, and hydrogen plus aqueous is going to be 0, F2 gas, chlorine gas has to be 0. Okay, and very important thing I want to say, look at this. Standard enthalpy formation of elements in the pure state at a standard state at a 298 Kelvin 1 bar is 0, fluorine gas इसका 0 होगा, mercury liquid इसका 0 होगा, iodine solid इसका 0 होगा. And some exceptions भी है. Some exceptions are also there. I am going to show you that. So species O2 gas is 0. बेटा O3 gas का 0 नहीं होगा. This is not a standard elemental state. सल्फर रोम्बिक का 0 होगा. सल्फर मोनोक्लिनिक और एक एलोट्रोप है. थर्मोडायनेमिक्स का हिसाब से ये रोम्बिक सल्फर का स्टैंडर्ड स्टेट लिया हुआ, सो इट इज गोइंग टू बी 0. एंड ग्राफाइट का 0 होगा, डायमंड का 0 नहीं होगा. You may say CO2, NO2, no, these are the compounds beta. These are the compounds. CO2 is a compound, not an elemental state, right? And generally the value of standard enthalpy formation of the most of the stable allotropes is 0. So you can say diamond is hard. It doesn't mean that it is stable, okay? And you know, it is graphite is said to be thermodynamically stable. It's an exceptions are there. White phosphorus, some exceptions are there, my dear children. So you have order of stability. White phosphorus is least stable, but thermodynamics takes this value as 0. It is an exception. क्योंकि कैलकुलेशन में आसानी रखने के लिए white phosphorus का 0 लिया. So though white phosphorus is taken as a standard, but it is the most reactive form of the phosphorus. You know, you take it out from this container, it is going to be simply ignited. It catches fire at room temperature. And red phosphorus का 0 नहीं होगा. So white phosphorus standard enthalpy of formation is taken as 0. Usually in any thermochemical equation we take standard enthalpy of formation of phosphorus is 0. Sulfur rhombic is 0. Okay, that's a very important noteworthy point. Okay, what do you like this? White phosphorus, of course it is white translucent solid and stored underwater because it catches fire when it is exposed to air and it is poisonous. And moving ahead, so enthalpy of reaction from enthalpies of formation. Simply you take enthalpy of reaction is equal to sum of the enthalpy of formation of the products minus sum of the enthalpy of the formation of the reactants. So here you have to take the stoichiometric coefficients here. And talking about enthalpy of combustion, the combustion, that itself gives you the overall picture about this. So enthalpy change of a substance, when 1 mole of a substance is completely subjected for burning or combustion in sufficient amount of oxygen, that is called enthalpy of combustion. it is supposed to be always exothermic beta. It is supposed to be always exothermic. Okay, so it is a glucose. Glucose is subjected for combustion, gives rise carbon dioxide and water. It is going to be 2802 kilojoules. That much energy is given. So we are all surviving due to the combustion of the glucose only. And also graphite on combustion gives rise carbon dioxide. The value is going to be minus 393.5. Please don't memorize these values. Okay. But you don't have to memorize these values. So these values are shown for better understanding. I will tell you when to memorize. Okay. As a teacher, I never insist you to memorize. Understand the concept and do the concept as it is required. And bacho here calorific value. Calorific value. अरे nowadays whenever you eat something उसमें carbohydrate है, protein है, fat है, उसमें calorific value कितना है? So yeah, I'm coming to that point only. Sahil, wait, lot of patience is required, beta, lot of patience is required. You see, so calorific value means the enthalpy change, the heat liberated when 1 gram of the substance is combusted. I mean to say here calorific value Cv is equal to enthalpy of combustion upon molecular weight. That is very important. So that is very important. And these applications of the enthalpy of combustion is the better understanding the terms of calorific value and to determine the enthalpy of reaction. And you see here in the calorific value, the amount of heat released during the complete combustion of a unit mass, generally it is going to be 1 gram of the substance. So calorific value is going to be enthalpy of combustion upon molecular weight, and it is going to be joule per gram or calorie per gram. So fuels are fuel efficiency is measured in terms of calorific value. The one which has more calorific value is going to be the better fuel. That's very important. So in the NEET examination, you will be given a question which is the better fuel. It all depends upon calorific value, but tactically enthalpy of combustion value देख के आप उल्टा आंसर दे सकते हो, but you have to use the calorific value. Fuel efficiency is directly proportional to calorific value. ख्याल में रखो. H2, yeah, and you see here, determine the enthalpy of reaction. That can be done. C2H4 ethene on addition of hydrogen. This process is called hydrogenation. You get ethane. It is the best fuel. Hydrogen is the best fuel, exactly, and is eco-friendly also, Sahil. And you can see C2H4 combustion करके you are going to get CO2H2O. H2 combustion करके H2O मिलेगा, and C2H6 combustion करके you are going to get again CO2 and H2. And the difference between these two parameter combustion values, you can get this enthalpy of reaction. And using Hess Law directly you can use this. Okay, hydrogen Cv is 154 kilojoule per mole. Yeah, probably. And you are going to see enthalpy of reaction is equal to sum of the enthalpy of combustion of the products or reactants minus sum of the enthalpy of combustion of the products. So here reactant minus product आना चाहिए in the combustion में. And also calorimetry. How do you get the heat of combustion process? Heat of combustion process is attributed by using a calorimeter, a device. Okay, that device appears like this, and measurements are made in two different conditions. It could be at a constant volume, it could be at a constant pressure. So heat of a system at a constant volume is said to be internal energy change, and heat change at constant pressure is said to be enthalpy change. But calorimeter is going to be a closed system, and in that constant volume में करना पड़ता. So that I just want to say delta U measurement is done by using a bomb calorimeter. What is this bomb calorimeter? मेरा बचपन में सोच रहे थे bomb क्या होगा. So teacher wanted to take to the laboratory and wanted to show something. So bomb फाड़ के कुछ दिखाना चाहता हूँ. टीचर में सोच रहे थे bomb calorimeter ऐसा नहीं होगा, bomb calorimeter होता है ऐसे. Okay, so it is a device where a small container is taken, in that a piece of biscuit or a piece of bread is made, that is called sample cup, and it is subjected to sufficient oxygen and it is kept in the water, and there are some electrodes, ignition box hoga. By using these electrodes we are going to make it is combustion, so that heat transfer takes place. Due to heat transfers by using these paddles it is going to be homogenized, so that temperature change is observed, that is going to be delta T is equal to T2 minus T1. That only you have to measure. Once you measure that, what you can do it here, bacho, you can do heat evolved. Heat evolved during the reaction is transferred into the water around it, here water around it, so that the temperature of the water is monitored by using thermometer. And this temperature change is very important, and this temperature change is very important, which can give you mathematical relation between the heat of a reaction and enthalpy change. You can use this, a golden formula, Q is equal to, Q means heat change at constant volume. I want to say delta U is equal to mass of the water and the specific heat of the water, delta T plus C delta T. So here M is going to be the mass. So by the use of bomb calorimeter we can measure the heat of neutralization also, and C is the heat capacity of the calorimeter system. Calorimeter itself has some heat capacity, and S stands for specific heat, delta T is going to be T2 minus T1. That only you can measure by putting these values in the experiment, and you can calculate directly delta U. अरे delta H कैसे कर सकता हूँ? Delta H can be calculated delta U plus delta nRT. So what is delta N? So we discussed in the thermodynamics, delta N is equal to sum of the number of gaseous products minus sum of the number of gaseous reactants. So in order to do numericals, I always strongly recommend my dear students, thermochemistry is such an easy topic. You can learn this thermochemistry from thermodynamics, terms and definitions. So stay tuned in the class and take a noteworthy points. This is well explained, self-explanatory points. Okay, my dear children, here, so Q is equal delta U is equal to M plus W E S delta T. What is this? Water equivalent. थोड़ा सा derive करना. Mass of water that would absorb the same amount of heat as absorbed by the stirrer, thermometer and a bomb, etc. Okay, and physics में जाके इतना depth में देखना पड़ता. And also enthalpy changes during phase transformations. Phase transformation means it could be melting, that is called fusion. It is going to be evaporation, liquid to gas, and sublimation, it is going to be solid to vapor. Right, moving ahead. Dear children, enthalpy change when 1 mole of the solid is completely converted into the liquid state is called a melting. So this happens at its melting point, that is called enthalpy of fusion. अरे this is the definition बेटा, ये definition का हिसाब से condition क्या होगा at the melting point में होगा. You say states of matter is not there in the chemistry, but it is required. So H2O solid is converted into H2O liquid at 0 degrees centigrade. So always positive, and it is an endothermic process. And want to say enthalpy of evaporation, the liquid is converted into vapor. When it will have, it is going to evaporate at its boiling point. H2O liquid is going to be converted into H2O gas. It will happen 100 degrees centigrade, mean to say 373 Kelvin. That is very important. And this is also endothermic process. And also you can say enthalpy of sublimation. So what is the meaning of enthalpy of sublimation? It is the enthalpy change when 1 mole of the solid is directly converted into vapors at sublimation temperature. So actually you say solid has to be converted into liquid, is converted into vapor, is converted into vapor. And in this scenario, liquid state is a metastable. So this process, it is going to be enthalpy of sublimation is equal to enthalpy of vaporization and fusion plus enthalpy of vaporization. So such type of substances who is going to be sublimated, इसका enthalpy of fusion Hess law इस्तेमाल करके आप कर सकते हो, right बेटा? अपना song कुछ बोलना चाहता हूँ? As you said, carbon dioxide is a solid. Dry ice is converted into carbon dioxide in the gaseous state. It requires endothermic plus 25.2 kilojoules. And also you can say enthalpy of transition. So one form of an allotrope is converted into another form of an allotrope. That is called enthalpy of transition. So graphite, and it is a diamond. How many of you like this diamond? So precious. So the transformation of graphite is converted into diamond, and that transformation 1.9 kilojoule per mole काफी बड़ी important है. You know the process which can convert the graphite into the diamond in the artificial diamonds, ये method इस्तेमाल करते हैं. That process is there in the group 14 elements, is called H-Sun process. H-Sun process. Okay, and you can also see here enthalpy of atomization. So it is very important, enthalpy of atomization. Chemistry, chemical bonding में काफ़ी definitions आपको दिखाना. Okay, and Sahil, first you need to be very clear about all the definitions, then we can jump into the numerical. So stay tuned, my dear students. Now here enthalpy change when 1 mole of substance is converted into gaseous atoms. Gaseous. The substance can be a diatomic substance. So H2 is a gas and it is converted into H2 atoms. So it is so energetically costly, and if it is diatomic, it is going to be bond enthalpy. Okay, and if it is more than a compound, it is going to be mean bond enthalpies has to be taken into the consideration. Here you can see bond dissociation energy, stability of the molecule is directly proportional to bond dissociation energy. Okay, enthalpy required to dissociate a given bond of some specific compound. H2 is dissociated to hydrogen atoms. So it is a bond dissociation enthalpy. If it is a polyatomic molecule, you have to take the average. You can say methane, carbon with 4 hydrogen atoms. All bond energies is not actually same. In that case, you have to take the average. Let me take how to take this average. check this 1 bond is broken here. Okay, so CH4 1 hydrogen काट दिया, so 427 energy is required. और एक हाइड्रोजन काट दिया, so that you are going to say 439. और एक हाइड्रोजन काट दिया, you are going to see 452. And last hydrogen is removed. I want to say there are 4 hydrogens. In these 4 hydrogens, we have to break one hydrogen. So this is the hydrogen 1. This is the hydrogen 1 is broken, and this is the hydrogen 2 is broken. This is the energy. Hydrogen 3 is broken. This is the energy. Hydrogen 4 is broken. This is energy. So carbon to hydrogen bond energy. Carbon to hydrogen bond energy has to be taken average 427 plus 439 plus 452 plus 347. So there are 4 bonds has to be broken. So for polyatomic molecule, you have to take the average bonded dissociation energy. So the overall energy to break these 4 bonds is going to be this much and has to be divided by 4. So that is going to be 416 is the average bond dissociation energy. मैं क्या बोलना चाहता हूँ, for polyatomic molecule you have to take the average bond dissociation energy into the consideration. This is a very important, and based on this you will be having a direct question from thermodynamics, you will be having a direct question from chemical bonding also. Their bond parameters सिखाओ ना आपको. So bond dissociation energy, here it is average लेना पड़ता. And also my dear children, applications of bond energy, stability a molecule सीधा ये stability आप ले सकते हो. So determination of enthalpy of reaction. Whenever you take this bond C2H6HCl, so you are going to be adding the HCl according to the electrophilic addition reactions in the organic chemistry. So how much energy is required to break the old bonds and the new bonds? For that you need to say sum of the internal energy that is given here. Okay, resonance energy. So resonance energy is the difference in the one of the stable resonating structure and the resonance hybrid, and that energy is used for the stability of the molecule, that is called resonance energy. So benzene has its various resonating structures, and this is one of the canonical structure. इसका भी और एक ले सकता हूँ मैं, and इसका energy ये, so शायद here होगा, and this is a resonance hybrid, and resonance hybrid will have always less energy as compared to its canonical structures. The energy gap between resonance and resonating structure, hybrid and canonical structure, the energy gap is called as resonance energy. Are you getting or not? And more is the resonance energy, more is the stable the molecule, and you can say, you can experimentally you can calculate, Sahil, resonance energy always negative, ख्याल में रखो, and is equal to the difference between experimental enthalpy of formation minus theoretical enthalpy of formation. It is theoretical means it is calculated based on bond energies. Any doubt? आज थोड़ा खांसी चल रहा है because of the cold weather, and hope class don't have any obstructions here. Dear children, if you have any doubts, please. साहिल कुछ डाउट पूछते नहीं, आगे न्यूमेरिकल्स देखा ना हो बेटा. Now let us talk about determination of resonance energy, and NEET examination में अगर toughest paper आपको देना चाहता हूँ तो उससे दे सकता हूँ, right? Resonance energy is equal to enthalpy of combustion calculated minus enthalpy of combustion experimental, or else resonance energy can also be calculated enthalpy of hydrogenation, alkene होगा तो थियरिटिकल माइनस एक्सपेरिमेंटल. सो कंबशन से निकाल सकते हैं, हाइड्रोजनेशन से निकाल सकते हैं. दैट्स वेरी 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 इंपॉर्टेंट. ओके, सो यू वांट टू रिवाइज द एंटायर कॉन्सेप्ट. ऐसे आपको लगेगा 2-3 दिन लगेगा. एक ही 2 घंटे में हम ये टोटल कॉन्सेप्ट आपको रिवाइज देना चाहता हूँ. दैट्स वेरी इंपॉर्टेंट बेटा, वेरी वेरी इंपॉर्टेंट फॉर यू, राइट. नाउ मूविंग अहेड हियर, lattice energy. What is the meaning of a lattice? Crystalline solid of ionic compound is called as a lattice. Okay, so energy released when 1 mole of a solid ionic compound is formed from its constituent gaseous ions is called as lattice energy. I mean to say here, sodium plus in the gaseous state and Cl minus in the gaseous state पकड़ के sodium chloride solid is formed and that is lattice energy. That energy released during this process is called lattice energy. Lattice enthalpy of ionic compound can be determined indirectly by using a Born-Haber cycle. Stability of ionic compound is based on lattice energy. Fine, let's start with the Born-Haber cycle for lattice energy to calculate sodium chloride. So, just recall what is Hess law of constant heat of summation. बच्चों, you can see ये gives rise to D and A gives rise to B, B gives rise to C, C gives rise to D. Here it is a Q and it is going to be Q1, Q2 and a Q3. Hess law बोलना चाहता हूँ Q is equal to Q1 plus Q2 plus Q3. द सेम कॉन्सेप्ट में इस्तेमाल करके सोडियम क्लोराइड का लैटिस एनर्जी निकालने की कोशिश कर रहा हूं. ठीक है बेटा. दोज हु आर ऑनलाइन प्लीज लाइक द सेशन एंड फॉलो माय सेशन फॉर दिस. 1 minute प्लीज. So moving ahead, the lattice energy. Calculation of lattice energy by using a Born-Haber cycle. ये साइकिल देख के आपको थोड़ा सा डर लगेगा, but I am going to fragmentize this and I will show you the best way of NaCl formation. Na sodium is a sodium metal is a solid state. See the state of the matter also. Combined with half chlorine which is in the gaseous state. And these two combine to give rise sodium chloride. This is called thermodynamics के हिसाब से enthalpy of formation. This is a direct step. Lattice energy is not this. Lattice energy is the energy that is released when ion is converted into solid. Here ion is not solid. So indirect में लिखना पड़ता हूँ. सोडियम से सोडियम गैस आना है, that is called enthalpy of sublimation. एक्सपेरिमेंटली ये वैल्यू निकला. एंड आइसोलेटेड गैसेस न्यूट्रल एटम, इससे एक इलेक्ट्रॉन निकाल के सोडियम प्लस बनेगा, दैट इज कॉल्ड आयोनाइजेशन एनर्जी. दिस वैल्यू इज आल्सो कैलकुलेटेड एक्सपेरिमेंटली. टॉकिंग अबाउट क्लोरीन, this chlorine gas is a molecule is divided into its chlorine atom. This is what is called enthalpy of atomization and this is बॉन्ड डिसोसिएशन एनर्जी. एंड इससे एक इलेक्ट्रॉन ऐड करना चाहता हूं सो Cl माइनस बनेगा. दिस इज कॉल्ड इलेक्ट्रॉन गेन एंथैल्पी. यू नो दिस वैल्यू इज नेगेटिव. इलेक्ट्रॉन एफिनिटी इज नेगेटिव ना. एंड अभी तो फिलहाल सोडियम प्लस एंड Cl माइनस तैयार हैं. ये दोनों मिलके आपका सोडियम क्लोराइड मिलेगा. I want to say here the net enthalpy change of a chemical reaction of any process is always remains the same because we are taking the help of Born-Haber cycle, and these two are going to give you, it has to be calculated by using Born-Haber cycle. So I mean to say here, let us say enthalpy of sublimation, enthalpy of formation here is equal to enthalpy of sublimation plus enthalpy of ionization plus enthalpy of bond plus enthalpy of electron gain plus lattice energy. By using algebra, you can calculate the enthalpy of lattice. And hi Betu, how are you? Happy New Year. How are you? Happy New Year. And all the values will be given. You are asked to calculate enthalpy of formation or enthalpy of lattice or electron gain enthalpy, जो भी है, ठीक है बेटा? Sahil, Betu, you came late. Why so? I'm expecting you to be on time. Today we are discussing thermochemical equations. Now talking about enthalpy of hydration. So this is the enthalpy change when 1 mole of the gaseous ions is dissolved in large extent of the solvent to get hydrated. This is called hydration energy. So it is for the gaseous ions, for anhydrous partially hydrated salts. These are two types. This is of two types. And let us talk about enthalpy change when anhydrous copper sulfate solid, it is white in color. So when you just expose it to air, it is going to absorb all the water molecules in the air and it is going to be converted into copper sulfate dot H2O. आपको कैसा पता चलेगा? क्योंकि ये white color solid ये blue color को change करना है. So enthalpy change when anhydrous or partially hydrated salt combines with a required amount of water to form a new hydrated stable salt is called as enthalpy of hydration in this partial hydrated salts. And also you can say enthalpy change. So enthalpy change in the solution. I mean to say enthalpy change happens when 1 mole of subsolute is dissolved in large excess of solvent, so that further dissolution does not involve any heat change. So sodium chloride is converted into Na plus and Cl minus ना. This is called dissolution process. उसमें lattice break होना, lattice break होने के बाद आपको ions मिलना, ये ions solvate करना. So enthalpy of solution is equal to lattice energy plus enthalpy of hydration. So this is very important. So these are the expressions that is important to solve the questions in thermochemistry. That's why Sahil, you were asking continuously numerical shuru karo, numerical shuru karo. So unless we have a clear picture on the concept that I am going to give, you have to get the clarity. तभी आप numerical कर सकते हैं. Right? Doing numericals, I did 100 numericals, you did 200 numericals, you are great. You learn concept so firmly, do 5 numericals काफी जलता है, right? So that is creating an impact. Moving ahead here, enthalpy change of a solution, integral enthalpy change. I mean to say, if it is a large excess, प्रैक्टिस भी होगा, कोई प्रॉब्लम नहीं बेटा, प्रैक्टिस भी होगा, right? Enthalpy change when 1 mole of solute is dissolved in definite quantity of the solvent, that is called integral enthalpy of solution. Like HCl 10H2O molecule लेके HCl dot 10H2O होगा minus 69.5. Don't memorize this value. HCl 25 भी ले सकते हैं. No problem beta. No, I don't accept your sorry because we are all friends na. Delete the message and say Happy New Year. हम खुश हो जाता. Happy New Year to you also Sahil. Right. So it is going to have fixed number fixed number of the water molecules. Beto, right? And also, you can say HCl 25H2O, you are going to be minus 72. And HCl 40 HCl H2O भी ले सकता हूँ क्योंकि it has a strong affinity towards the water. It is going to take n number of the water molecule. That is called integral enthalpy of solution. Okay, partial hydrolysis, partial dissolution, and everything. Thank you, Sahil. I wish you the same. Happy New Year and bless you. You will be having a colorful New Year 2026. So all my blessings are with you, all my students. Okay, moving ahead, enthalpy of dilution. I mean to say a fixed concentration solution का थोड़ा सा dilution करके, fixed dilution करके आपको जो मिलेगा ना, and enthalpy change when a solution of 1 mole of a solute is diluted for higher concentration to lower concentration is called as enthalpy of dilution. You know, enthalpy of dilution depends upon nature of the solute. Okay, dissolving gaseous HCl in the water and you will get a dissolved HCl, and the dissolved HCl is going to give another concentration. Okay, and after this Kirchhoff equation we will start numericals. Okay, stay tuned. It relates the enthalpies of reaction at 2 different temperatures. That is Kirchhoff's equation. So that is given as, look at this, yes, it is Kirchhoff equation. Delta H is equal to delta H naught minus delta H naught 2 minus delta H naught 1. So if you take this in this way, delta H2 minus delta H1 is equal to Cp delta T. So delta T is equal to, I mean to say, delta H2 minus delta H1 is equal to delta Cp and delta T. So you can directly use this and you can measure at a T2 minus T1 is equal to delta T. So इससे आगे बढ़ने तो you are going to have n number of variants of the Kirchhoff equation. Same equation उधर उल्टा फुल्टा करके आपको दिखाई देना चाहता हूँ. And let us talk about Kirchhoff equation in different way. Yes, that is if delta H2 is equal to delta H1 plus the integral करके ये वाला T2 to T1 के integrate करके and Cp delta T का दिया. Okay, and also you will be having Hess Law constant heat of summation. We did it, right? And I want to come across with some numericals here. All right. Now, in the reaction CO2 plus H2 gives rise CO plus H2 delta is equal to 2.8 kilojoules. So, the delta H represents, what is this delta H? Heat of formation, heat of reaction, heat of solution, heat of combustion. I want you guys to give the answer in the chat box. So, you all know the definitions, no? Just based on definitions, you tell me. Sahil, you tell the answer for this question. You tell the answer for this question. So, waiting for you. It indicates enthalpy, heat of formation. So, it is not heat of formation, heat of reaction better. This is a heat of reaction. Heat of reaction. This is about the B. Heat of reaction. Because heat of formation होने के लिए reactant should be in the elemental state, right? And moving ahead, the enthalpy change for H2O gives rise to H2O liquid. Solid is converted into liquid. It is called. So solid liquid करने के लिए process is called as enthalpy of fusion, right? So it is going to be enthalpy of fusion. Numericals भी है. हमारा सेशन पे numericals पे थोड़ा सा theory oriented questions 1, 2, 3 करके. And you can see one more. Which of the following pair has heat of neutralization equal to 57.1? You know, whenever a strong acid and a strong base combine to give rise to salt and water, delta H is equal to minus 57.1 kilojoule per mole. So you can say strong acid H plus देते हैं, strong base OH minus देते हैं, ये दोनों मिलके आपको H2O form, enthalpy of formation of water. So delta H is going to be minus 57.1. So a strong acid and a strong base. Okay, so my answer for this question is going to be A, it's not B. Fine. Children, moving ahead, RH is there. Now starting with the numerical. Will you do this numerical or you want me to do this numerical? You tell me. There should be a deal between you and me. Come on. So far presentation is there. Now it is a practice session. आज का टर्मिनल में क्या होगा? Thermodynamics, thermochemical numericals practice session में. Okay. So why means no will you do this question or you want me to do this question? So there should be a deal between you and me. Okay, Satya. Here I want to say calculate the amount of heat evolved when 500 cm cube means milliliter beta. So number of equivalents of hydrochloric acid. So number of moles of hydrochloric acid is going to be 0.1 upon 1000 into 500 is going to be 0.05, right? Talking about 200 milliliters of sodium hydroxide. So the mole of sodium hydroxide comes to be 0.2 upon 1000 into 200. So I got it 0.04. So who is going to be the limiting reagent? I would definitely say this is going to be the limiting reagent. आपका जो प्रोडक्ट देना चाहता हूँ लिमिटिंग रिएजेंट का हिसाब से देना पड़ता हूँ. So I want to say here, so 0.04 into 57.1, you are going to get 2.284 kilojoule आसपास में मिलेगा. So the answer for this question is going to be A. So this is how the simplest way. Very good, nice. Previous slide, आपको previous slide दिखाना. Okay, Satya, you do it. Yes, sodium hydroxide is going to be the limiting reagent in the previous slide. So this is how. Previous slide you wanted to know. Sahil. हो गया Sahil, right? And this is the question, we did it. Answer is going to be yeah. Any doubt with this? You have to calculate the number of moles of HCl, number of moles of sodium hydroxide, strong acid, strong base. So sodium hydroxide is 0.04 is the least, so we will give according to this. Okay, any doubt? Sahil? Satyam the Great. Moving ahead, one more. Calculate the enthalpy. change accompanying the transformation of carbon graphite से carbon diamond मिलने तक, given that the enthalpies of combustion of graphite is given, enthalpy of combustion of diamond is given. Now, who will give the answer for this question? I will solve it. Will you, Satyam, Sahil, Betu, come on, will you solve or you want me to solve? Okay, we'll see what exactly it is given here. Answer is B, of course. Let us see. Let us see how this can be. Here, first of all, given that enthalpy of combustion of graphite is given 393, enthalpy of combustion of diamond is given 395. So, if we want to change graphite to diamond, na, reverse the second equation so that diamond become a product, graphite become a reactant, add them. If you add them, okay, you will be getting, we aim to see graphite से see diamond, so ये जो transformation के लिए कितना होगा? Kinwang. So we can take the second reaction in subtracted and put it here. So graphite to diamond मिलेगा. So it is going to be subtract. You are going to get plus 1.9 is the answer for this question. So the answer is plus 1.9. Simple, simple you can say, or otherwise you can write this equation in the different format. C graphite plus O2 gives rise to CO2. Okay, so delta H is equal to minus 393.5. In a simplified version I will do it. If we reverse this second, so CO2 gives rise to C diamond plus O2. Delta H is equal to plus 395.4. If you do so, C graphite become C diamond. So delta H is going to be, sum is going to plus 1.9 is coming. Simple na? This is my trick. This is my trick. दिखाई दे रहा है क्या? This is a systematic procedure I wanted to present to you. Satyam, any doubt? Bachcho. Moving ahead. So calculate the enthalpy of hydration of anhydrous copper sulfate into hydrated copper sulfate dot 5H2O. Given that the enthalpies of solutions of anhydrous copper sulfate and hydrated copper sulfate are 66.5 and plus 11.7. So under given data सोचना बेटा पहला. Actually my lectures will be every day. We will be given a concept short videos and recordings, and in weekly 2 days we will be given a live lecture for you on the YouTube platform. So first you subscribe to Infinity Learn Neet YouTube channel. Whenever the session is going to happen, when you subscribe it, automatic notifications will be coming to you. Fine? Sachyam, so ये करने के लिए, so copper sulfate dot 5H2O is dissolved, that is given plus 11.7. And also answer is A. Let me solve and I'll show you. And if I take this copper sulfate solid is dissolved, so enthalpy of dissolution is given minus 66.5. So I wanted to say, this question is asking about copper sulfate से copper sulfate pentahydrate बनाने के लिए कितने एनर्जी चाहिए इसको. Simply take this into second equation, उल्टा करके उसमें लिखना. So we aim to get copper sulfate solid 5H2O gives us copper sulfate 5H2O. ये enthalpy of hydration कितना होगा? So that we have to understand. Simple. Copper sulfate solid ये reactant में आना चाहिए. And copper sulfate dot 5H2O ये product में आना चाहिए. सो सेकंड इक्वेशन रिवर्स करके फर्स्ट इक्वेशन से सब्ट्रैक्ट करो, सो आपको मिलेगा यू आर गोइंग टू गेट -78.2. Are you getting or not? This is the best way to solve the thermochemical equations. Are you getting or not? Or you want me to solve by my handwriting? That also I can do it. Right? Satyam. Now moving ahead, bachcho, and calculate the enthalpy of formation of methane. So मीथेन फॉर्म होने के लिए हमको क्या चाहिए? हमको चाहिए कार्बन ग्राफाइट चाहिए प्लस 2 हाइड्रोजन गैसेस चाहिए ताकि आपका CH2 गैस फॉर्म होना डेफिनेशन का हिसाब से. Next, so that given that enthalpies of combustion of methane, graphite, hydrogen are given, so that उसमें product and reactant, product minus reactant gives rise to the enthalpy of formation, and I am going to get the answer here with that. You can see how it is. So it is given as CH4 enthalpy of combustion, it is given 890. Look at this, 890 is given now. Yes, these values, and 393 and 285. And moving ahead, and that is going to be 890 enthalpy of combustion of graphite, 393.4 enthalpy of combustion of hydrogen, 285. We aim to calculate carbon plus hydrogen gives rise CH4, and methane minus carbon plus hydrogen into 2. So we'll do it. In order to get this thermochemical equation, multiply this, and you're going to get carbon plus hydrogen gives us CH4. So that is going to be 393.4 negative plus 2 into minus 285.7. On doing so, we are going to get minus 74.6 kilojoule per mole. Fine. So, dear children, we will be giving so many examples, awesome examples. You can no wonder if you see this kind of questions even in your NEET 2026, no worries, it will be. And you can say which of the following enthalpies is always negative? Always negative. Enthalpy of solution, combustion, sublimation and formation. अरे एंथैल्पी ऑफ कंबशन हमेशा एक्सोथर्मिक होगा, so that it is going to be delta H is going to be negative, right? It is going to be negative. So my answer for this question is going to be B. Sahil, where did you go? Discussing the questions for you. Now, so standard enthalpy of formation of HCl, hydrogen, chlorine is given like this, and the bond dissociation energy of the HCl is. So the solution is available 431. Bond dissociation energy, it is supposed to be endothermic process. HCl is converted into H gas and chlorine gas, and this bond dissociation energy directly plug and play, and my answer is going to be A. Any doubt, bachcho? Okay, next, moving ahead, और एक है that you have to say an imaginary reaction X gives rise to Y takes place in 3 steps. Step 1 में X gives rise to A, and delta H is going to be Q1, and B gives rise to A, and delta H is going to be minus Q2, and y gives rise to b, delta H is equal to minus Q3. Now, मेरा सवाल है कि if Hess law is applicable, the heat of the reaction जब x gives rise to y, आंसर क्या होगा? आंसर क्या होगा बेटा? Look at this. The data is visible. Will you do or you want me to do? Satyam, come on. Sahil, Betu, waiting for you. And x gives rise, takes place in 3 steps. Na? X gives rise to y. So that I just want to flip this here. I want to flip this here. So I want to say x gives rise to y, right? B gives rise to a, and x gives rise to a. Let me say x gives rise to a and b gives rise to, so let me flip this, a gives rise to b and y gives rise to, b gives rise to y. So if you add, so you are going to see ये काट जाएगा, so x gives rise to y. So इसका minus q1, इसका plus q2, इसका ये भी उल्टा किया ना, so it is going to be plus q3. So the sum is going to be the answer is going to be A. Clear? And it is how it can be seen, that is going to be. On doing so, we have Q2 minus Q1 plus Q3. Anush, how are you? Happy New Year बोलने के भूल गए आप. मध्य प्रदेश से. Happy New Year बेटा. Now moving ahead, और एक क्वेश्चन है आज. For which of the following reaction delta G H is greater than delta U? उसमें कॉन्सेप्ट क्या होगा? सत्यम, अनुज, बेतु, Sahil. Here I want to say delta H is equal to delta U plus delta nRT. Delta N is equal to sum of the number of moles of the products minus sum of the number of moles of the reactant in the gaseous state. If delta N is equal to 0, then delta H is equal to delta U. If delta N is greater than 0, then delta H is greater than delta U. If delta N is less than 0, delta H is less than delta U. Now this is the concept. Based on this concept, you can say which of the following delta H is greater than delta U. So delta H is greater than delta U, ये कौन सा कंडीशन में वैलिड है? So let me calculate delta N इसका आता है 2 minus 1 plus 3 is equal to minus 2. नहीं होगा. So similarly you can say delta N is equal to 1 plus 1 minus 1 is equal to plus 1. Yes, इसका होगा. So my answer for this question is going to be here answer C is the correct answer. So हर एग्जाम्पल का, हर ऑप्शन का आप खुद कर सकते हैं. ठीक है? अरे this is the style you have to inculcate to do the questions from the NEET examination. NEET examination is not going to ask you how depth you know the subject and how complicated numericals you can handle, but NEET is going to try to explore what is your understanding ability, how to tackle the basic simple numericals. So you should be fundamentally so strong in the subjects, right? Fundamentally so strong. That is the advice I want to give you. Okay. Now moving ahead, or a question I'm going to pass. Difference between heat of a reaction at constant pressure and a constant volume. How to calculate this? How to calculate this? Heat of reaction at a constant pressure means delta H. At a constant volume means it is going to be delta U. So that delta H is equal to delta U plus delta nRT. The question is delta H minus delta U is equal to delta nRT. बस डेल्टा एन निकालना है, ये इसका लिक्विड का जीरो ले लो, गैस का कंसिडर करो, गैस का कंसिडर करो, लिक्विड का जीरो ले लो. Are you getting or not, my dear children? Now I want to say the answer is A for the reaction at constant pressure, delta H, for the reaction at constant volume, delta U. Delta U and delta H minus delta U is equal to delta nRT. इसका delta n3 होगा -3 इंटू R वैल्यू 8.314 लेना है, क्योंकि इसका आंसर जो है किलो जूल्स में दिया गया. Into temperature 25 degrees centigrade is given to 98 Kelvin, so that you are going to get minus 7.43 into 10 cube joules, so it is going to be minus 7.43 kilojoules nikla. So the answer for this is going to be answer A. Answer A. If you have any doubts, please let me know. Consider the reaction H2 plus Cl2 gives rise to HCl, delta H is equal to minus 185 kilojoules. If 2 mole of hydrogen is completely react with 2 mole of chlorine to form HCl, what is the delta U for the reaction? Super combination. It's a super combination. Options भी trap जैसे लगते हैं. अनुज, Happy New Year नहीं बोला? Waiting for you. Now moving ahead, and the option is going to be D, 370 कैसे है, and it is going to be 1 mole and 1 mole, right? But it is asked to calculate delta U. Of course, this delta n is equal to 0, delta n is equal to 0, so delta H is equal to delta U. For Pranam beta, and you are going to see the same value for the delta H and delta U. It is going to be for 1 mole it is minus 185. For 2 mole, 2 into minus 185, that is going to be minus 370. Simple. Pranam. Happy New Year bolo. So 2026 is going to be excellent year. इतिहास में लिखो. We are attending the classes from Infinity Land YouTube channel, and you are doing the best. Those students, come on, any doubt? And who is going to do this question? Who is going to do this question? बच्चों, so एक क्वेश्चन पूछ रहे हैं. क्या पूछना चाहता हूँ? ये क्वेश्चन में आपका आना है the standard heat of formation of CH4, H2O and methyl alcohol are given minus 76 and minus 242 and minus 266 kilojoule per mole respectively. And you are asked to calculate the enthalpy change for methyl alcohol is hydrogenated to give rise methane and water. सो ए एंथैल्पी ऑफ रिएक्शन इसका क्या होगा ये डाटा का हिसाब से. Will you do or you want me to do? Come on, chance is yours. Waiting for your answer. So in this case, this is the required equation. Okay, let it be, answer is going to be minus 52 kilojoules. Bacho, and here delta H is equal to enthalpy of formation of products minus enthalpy of formation of reactants. So product क्या methane and H2O and reactants क्या methyl alcohol and hydrogen. You know इसका जीरो लेना पड़ता क्योंकि ये elemental state का है. So there is a confusion point in the middle of the examination. Iska data is not given completely. Okay, now for this, enthalpy of formation of methane plus enthalpy of formation of water plus enthalpy of formation of methyl alcohol minus enthalpy of formation of hydrogen. Plug the values. I said its value is going to be 0 now. So put it here. Yes, it is taken as 0, minus 57 millega. Fine. Any doubt, bachcho? Now moving ahead, or a question in. The enthalpy of combustion of C6H6 is minus 3250 kilojoules when 0.39 gram of benzene burnt in excess of oxygen in an open vessel. Open vessel means, so you are going to get heat at constant pressure. So the amount of heat liberated is, so you are going to calculate delta H. Will you solve this or you want me to solve? Will you solve or you want me to solve? Make it fast. Make it fast. Right, here the answer is going to be 16.25, let it be. The enthalpy of combustion of C6H6 is given according to the data. Let us collect the data. 3250, right? And also molecular weight of benzene is 78. Number of moles calculate karna, weight by molecular weight. So 0.93, 0.39 grams. So the number of moles. So on burning 0.39 gram of benzene liberate 0.39 divided by 78 into 3250 is going to be 16.25 kilojoules. Fine. Like that, the question may looks a big complicated scenario. Okay, but it can be solved in a simple way. Fine. Now, the enthalpy of solution of anhydrous, we did this, okay, right. Yeah, here it is a question. This is a super awesome question. नीट एग्जामिनेशन में ये सीधा क्वेश्चन आने का संभावना है. The enthalpy of neutralization of HCl by sodium hydroxide is 57.1 and that of HCN by sodium hydroxide is minus 12.1. The enthalpy of ionization of HCN. Actually, HCN is a weak acid. Its value is less than the strong acid and strong base. क्योंकि ये जो difference आता है ना, ये खुद ionize करके इस्तेमाल करता हूँ. So I can say simply 57.1 minus 12.1. So the difference is going to be used for the ionization. So it is going to be the difference in the energy of neutralization of enthalpy of ionization as the amount of energy required for is the ionization. And you can say HCl sodium hydroxide this much, HCN sodium hydroxide this much. So ये उल्टा करके आपको क्या होना, sodium hydroxide is removed and the enthalpy of ionization is going to be minus 12.1, minus of minus 57.1 is going to be 45 kilojoules is required to ionize HCN. Okay, I said by looking at this value, the difference between these magnitudes is going to be ionization. Fine beta. So like that you will be having so many calculations in thermochemistry. ये अधूर कहानी है. We can have C2H2, C2H4 plus hydrogen gives rise C2H6. Okay. So given the bond energy is this much, okay, you are asked to calculate enthalpy of hydrogenation. ये enthalpy of hydrogenation में क्या होगा? You look at this here. First of all, in this reaction double bond के लिए ये single bond बनाने का alkene का mole hydrogen add करके you are going to see one double bond is broken, then one hydrogen bond is broken, then new carbon to hydrogen bond is formed. So that negative sign will be used for the bond formation and positive sign will be used for the bond breaking. And so delta H is going to be calculated based on that. You can say hydrogen, carbon, so hydrogen to hydrogen, and you need to get a new compound like this. So a new compound is formed so that the difference in the bond energies, reactant minus product लेना पड़ता है जब bond energies आते हैं. So this is how you have to calculate the thermochemical numericals, and also the bond energies here, the same type of numerical, the heat of hydrogenation of ethylene. So ethylene means CH2 double bond CH2. In the same format you have to calculate it. Ethylene means ethine nahi hai beta. Ethylene means CH double bond CH plus hydrogen to hydrogen is going to give us ethane. Heat of a reaction means and sum of the enthalpies of product minus sum of the enthalpies of the reactant. So the values are given, directly put it here. So the bond energies values I want to take it here directly from there. Any doubt? These are the values, you just trace it out. 410 carbon to hydrogen ka. And if you plug it directly, you're going to get 170. Okay, in the different format of the numericals, right? So now the heat of hydrogenation is going to be minus heat of reaction. So iska heat of the hydrogenation supposed to be exothermic. Alkene stability is also calculated based on heat of hydrogenation. Stability of alkene is inversely proportional to heat of hydrogenation. जिस alkene का कम heat of hydrogenation होगा, जैसे alkene ज़्यादा stable होगा. So stability कौन सा factor में आपको decide करना? When it comes to alkenes, it is decided based on the hyperconjugation in the organic chemistry. Okay, sketches, right? That is very important. So the same heat of hydrogenation concept is integrated in organic chemistry concept of hyperconjugation. You will be getting number of alpha hydrogens into the action. So like that, organic chemistry and the physical chemistry are interrelated beta. And moving ahead, this we did it, this also we did it. Okay, in the different formats. Okay, we are done for today's class, my dear children, and we'll meet with more stuff in the next class. And hope you enjoyed today's class. Please like this session, share with your friends, and subscribe to Infinity Learn Neet YouTube channel so that you will be getting all the updates when the sessions are going to be. So I want to say Happy New Year and enjoy your preparation, trust your preparation and believe in yourself, and come across with a very good number of questions and mention in the comment box, and I am going to solve all the questions. Okay, thank you very much. Signing off, Suresh, Faculty of Chemistry. Happy New Year once again. Thank you. God bless you.